This is how I have hooked up my electronics to my raw S70 CNC router. And the router came with this, which is pretty neat. It's an Arduino that will run the GRBL firmware and act as a motion controller. On top of that, I mount a CNC shield with STEPA drivers on it. The only problem with this setup is that these STEPA drivers are a bit too tiny to drive my NEMA 23 3-amp motors. So instead of this, I got this. This is a TB6560 driver board. It supports 4 separate axes and it has a breakout for an old printer port. So this is intended to be run by a PC running software such as Mac 3 or Linux CNC. And I don't really like that idea because a PC is not a real-time system. So what a motion controller does is that it converts G-code, which is draw a line, draw an arc, etc., into actual motor commands like up, 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 left, 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 up, 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 left, 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 down, 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 etc. And a PC, since it's not a real-time system, can be interrupted at any time. So it can go up, 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 ooh, shiny, network package, and you will drop steps. So there are 1,000 things that can interrupt the PC at any time. So I want to have a dedicated motion controller that doesn't have a multitasking operating system in the background. So I'm back to the Arduino. I have soldered a breakout cable that just maps all the printer port pins one-to-one to the corresponding Arduino pins. And this is just basic stuff, no active components or anything. Actually, it's not all the printer port pins. I've just taken the motor commands, the step direction and step commands for the X, Y and Z axis. And then I have duplicated the Y axis to the A axis because I run my Y axis with 2 motors. So this will just duplicate all the commands to the Y axis to the A axis. The GRBL software doesn't support 4 independent axes, but this is not an issue for me because I will send the same commands to these 2 axes anyway. So the Arduino you connect to using a USB cable, and this just exposes a standard serial port. So it's basic serial port communication. But normally you would hook this up to a laptop or something, but I decided to hook it up to a Raspberry Pi instead. This is a Raspberry Pi 3. It has Wi-Fi and it just boots a regular Raspbian image and then loads a serial port to WebSocket interface. So my serial port is accessible through a regular WebSocket. This means that I can communicate with it through a regular web browser. So here I have a normal PC. I have powered, plugged in, but nothing else. And I can jog my machine through this web interface. And since it's a web interface, anything that supports a modern browser can do the same. So I will try to do the same here on a phone. You first need to connect to the correct WebSocket, and then let's see if we can actually do something. And you can also see on the laptop browser that it's using the same data. So for this I made my own breakout cable. First I actually tried this. Let's move away because it's quite loud. So this is a shield for Arduino that just maps maps the printer port to the corresponding GRBL pins. So this has the correct GRBL pinout. It even has these little jumper switches for switching between the GRBL 0.8 and GRBL 0.9 pinout, because they switch the pinout. The only thing I needed to do is solder on these two wires to mirror the Y and A axis. And I had some success with this, but I was a little bit naive, thinking that there was some kind of standard when it comes to printer ports and CNC. It turns out there isn't. So the pinout for the parallel port here did not match the pinout on the breakout board that I'm using, my driver board. So it had the correct pinout for the step direction and step commands, but it had the wire for step enable wired to spindle enable. That kind of worked because the spindle was always enabled, so the stepper motors were always enabled. You don't really want your stepper motors to be always enabled because they produce a lot of torque, but at least I could get my machine moving. However, I did not get the limit switches moving this way. I can connect the limit switches to this board, but I have opted to connect them directly to the Arduino instead. So the pinout for the limit switches were off, and yeah, simply didn't work even if I changed the wiring. Yeah, so that's it. My next experiment will be with this guy, an Arduino Duo, which will run a different firmware from the Arduino Uno. So this can run G2 Core, which is the software that is running on the Tiny G motion controller. That supports up to 6 independent axes. And what else? Yeah, it has a higher order motion planner. So the GRBL has constant acceleration, but this supports constant jerk. So jerk, you can see as acceleration is a change in speed, and jerk is a change in acceleration. So this can produce smoother motions and less jerky CNC control. So yeah.